We just learned at a high level what the PC boot process looks like. We can actually use our Vagrant and VirtualBox setup to see that in real time. As you might recall, Vagrant is a virtual machine manager that uses VirtualBox to actually run and execute the virtual machine. What that means is that we can see the Vagrant managed machines through the VirtualBox interface and see the system start up and shut down, manipulating it and learning about it as we go. So let's dive in by looking directly at VirtualBox. So the first thing to notice is the Oracle VM VirtualBox Manager. In order to open this, I simply open the VirtualBox application. You can see on the left side all of the Vagrant virtual machines that I have running, or that I have listed even. 4 machines total are running. We're only going to pay attention to the 4th one down that I have showing running. We can also see that here's the operating system login. If you were to walk up to a server in a server room and you open a Linux command line prompt, this is what it would look like. Vagrant hides all of this detail for us. Before we reboot the system and start to look at the boot process, let's look at how it works from the Vagrant command line interface. I can log into my Vagrant box, and there's a few important directories and things to be aware of. First, let's look at the mounted file systems. I'm just going to pick out a few of them by running mount and piping the output to grep4 ext3, which is specific file system format. This highlights 2 file systems to be aware of. One is the root file system. In this case, it's an LVM file system, which we can tell because it says vol group. Root is where it's mounted, /. This is the beginning of the file system hierarchy. We also have /boot, an entirely separate file system, and that's what we're going to learn about for the rest of this lesson. For extra credit, just type the mount command and learn about what all of these other file systems are for. Now we'll change directory to /boot. If we type ls, we can see that there are a lot of different files in here. These are all kernel and boot related files. Another command to be aware of is the uname command, which shows system information. If I type uname -a, it shows me some output about the system. In particular, the section that I've highlighted here shows that this is kernel version 2.6 and then some other numbers. This is the running version of the Linux kernel on this system at this time. I can show just that version using uname -r. Now, if I want to just see the files in /boot associated with this, I can use some of the shell tricks we learned in the last lesson. I can use ls/boot, and then I can show all of the files that match this string, uname -r. So this uses shell globbing and embedded command execution, this $parenthesis syntax, to show all of the files related to the current running Linux kernel. So let's look at what each of these files does. The boot config file, if I run file on it, is just a plain ASCII text file, meaning we can look at it with a text editor. This is a lot of configuration about how the Linux kernel is running. You can see that it's 4,564 lines long. The Linux kernel is highly configurable. We have symvers, initramfs, and system map, which we don't need to talk about in a whole lot of detail now, but these are important for the boot process. The most important file here is the vmlinas file. This is the actual compressed kernel image. When the bootloader starts, it opens this file and decompresses it. Now let's look at the GRUB bootloader. We talked a lot about what the GRUB bootloaders do in the last section. Now we're going to learn about GRUB, the Grand Unified Bootloader, which is the standard bootloader used on Linux systems. At this point, we're in /boot/grub. There are several files in here, most of which we can safely ignore, but we will go ahead and view the grub.conf file, which is the configuration file for GRUB. This configuration file shows which kernels are available to GRUB to start up. Let's look at it line by line. Skipping over the commented lines, which are indicated, of course, by the hash marks. Default equals 0 says start with the first listing. Programmers often start counting from 0 rather than 1 like the rest of the world. Timeout is 5, meaning you have 5 seconds to select a kernel to start. And then hidden means it's not going to show the menu for selection unless you interrupt the boot process. We'll see that in just a minute. Next is our actual kernels that we can choose from. You could use this to set up multiple operating systems on a single disk. For instance, I could be running CentOS on one partition, Ubuntu on another partition, or even Windows on a third partition. In this case, we actually have 2 operating systems. We have CentOS running a specific kernel version 2632-358. It's a very specific kernel build. And we have the second one running 2632-279. These are very similar related kernels, probably just with some security or bug fixes in them. This kernel flag shows exactly where the kernel is in the boot file system under VM Linux, and this is what we saw a moment ago when we were looking at the different files available. And then a whole lot of flags, which we don't need to cover in detail right now. Finally, it shows us the initial RAM disk, and then we can select the other kernel if we want. So most likely you won't need to edit this file very often, but when you do, the format is actually pretty simple. So we'll quit out of VI now, and we'll look at the boot process using VirtualBox. So here we are at our running, this is our Vagrant box. This is the same box we were just logged into, only this is as if we're sitting at the console. I'm going to go ahead and restart the system. This menu under Machine, Insert, Control-Alt-Delete indicates that I'm about to restart. Just as if you'd typed a Control-Alt-Delete on your Windows system. So we can see the Linux system starting down, we can see the VirtualBox BIOS interface, and I interrupt the boot process by just pressing any key on the keyboard. Now we're seeing the GRUB boot menu. As you recall, we saw 2 options in the grub.conf file indicating the 2 different kernel choices that we have. This is what that was indicating. We can switch between which kernel we want to boot with the up and down arrow, and we can edit the kernel options right here if we want to. Type E to edit. Now you see the same lines that we saw in the grub.conf file. This is indicating where the kernel can be found. This is indicating the path name and all of those other options we saw. And this is indicating the initial RAM disk. Now I just want to boot, so I can type B, and it boots the system. That's the most common startup sequence. All of the complexity is hidden away by that nice splash screen, and then we get this login prompt. Let's restart it again. Let's see if we can interrupt it and see a little more detail about what's going on. I can interrupt the boot process, and I'm going to hit E to edit this kernel, and E again on the kernel line, and I'm going to delete this section right at the end, RHGB. What that little argument does is hide all of the boot process complexity from us so we don't see it. Instead, I'm going to replace it with the confirm command. This is telling the system that I wish to confirm every service as it starts up. This is mainly so we can see how the boot process works. So I edited that, I hit return, and now I can press B to boot. It initializes all the hardware devices, that's what's happening now, and it starts mounting the file system, so at this point you can see some detail about what the system's doing. Starting at the top you can see remounting root file system in read-write mode. So this is telling the Linux kernel is accessing the root file system, that slash file system that we saw from the mount command, and mounting it so that it's writable. We mount some other file systems, we start some services that are important to the kernel, and at this point it's prompting me. Start service LVM2 monitor. So I can say yes or no. If I'm having a problem with some service, I can interrupt that and not accept that service now. Now this is an important thing to know about because if you're making changes to grub.conf or to services that start at boot time and you make a mistake, suddenly the system will no longer be bootable. So this allows you to bypass anything you may have broken, but not everything. So I'll say yes to this one, and here it's trying to start an iSCSI service, which I'll just accept. We're gonna probably accept just all of these options because we're not trying to debug a problem. IP tables is the Linux firewall process. We'll accept that as well. Here it's asking me start service ETH0. This is always the first network interface on a Linux system, and we'll learn more about network interfaces in a later lesson. So I'm accepting all of these options so that the system comes online, starting various services that are managed through the upstart process, the init process. And once all of these processes start up, we're going to see that login prompt come again. And finally, we're at the login prompt. So that's what the Linux boot process looks like. And this will be the same on virtually any Linux system you encounter. Now we'll go ahead and restart one more time so we can demonstrate what it means to boot into single user mode. As you recall from the run levels, single user mode is when the system doesn't have any network access and doesn't allow multiple users to log in. On some systems, you don't even need a password to access single user mode. I encourage you to enable password access to single user mode. So let's restart it again. As the system starts up, I interrupt it again, and I press E to edit, and I want to edit the kernel, so I highlight the kernel line and press E. And this time I'm going to delete the RHGB and type single, which will boot me to single user mode. I press enter and then B to boot, and it's going to go ahead and run through the device initialization and some of the services. But notice that it right away drops me to a shell prompt that says root at localhost. This indicates that I am now the root user on the system. There's nobody else logged in. There's no network up. So I can't do anything, but I could debug a problem that existed only in one of the other run levels. This is a great and handy way to debug problems during the boot process. If I want to change to another run level from here, I can type init3, which will switch me to a run level that has multi-user mode and networking support. So at this point, it's going through all of those same services that we accepted before and gives me a login prompt. That's the basics of the Linux boot process.